long line. This is longer, and then one. So, tell me what this is right here. 1.25. Okay, so I hear some of you say 5. Did anybody think maybe 1.24? Maybe 1.26?
1.25, 7, 8, 9.
Okay, no, we can't go there. And let me tell you why. So, did you measure this 1?
Yes.
Did you measure the 2?
Yes.
Yeah.
Did you measure the 5?
No.
What is it?
Eyeball.
It's an estimate.
Right.
It's not calculated, it's an estimate. So you measured all 3 of these numbers. This is a direct measurement because you measured it. But these 2 are totally accurate. This one right here was your estimate. And somebody might have said 1.24, somebody might have said 1.25, maybe somebody even would have said 1.23. In any event, when you measure something, the last number always represents your estimate. So in surveying, we're going to be measuring distances with a tape. We're going to measure angles with the theodolite or the total station. We're going to measure distances with the total station. We're going to measure things, and we're always, the last number we report is an estimate. Okay? So let's take a look at now. You know, I didn't understand this part about scientific No, we don't use scientific notation in civil engineering. We prefer 100,000 acres. We don't want a 1 times 10 to the 5th acre. We don't use scientific notation, we use real numbers. But I never understood this in significant digits. All these rules always confused me until I had to teach this class, and then I finally got what was going on. Let me show you something. So I'm going to go to the packet. And I'm going to download it because I remember it always seems to work better when I download it. Not really quite sure why. I'm going to go to the first homework. So let's look at number 7, right? It says, give the answers to the following problem with the correct number of significant digits. So these are numbers that are measured, right? So A, I measured 19.27. Which one's the estimate?
7.
I measured 7. I measured 0.00145. What's the estimate? 5. I measured 165. What's the estimate?
5.
I measured 7.9. What's the estimate? 9. Now, when I add all these up, I want the last number to represent the estimate, right? So somebody pull out a calculator. We're going to need calculators in this class all the time. Add those numbers up. 19.27 plus 0.00145 plus 165 plus 7.9. What number do you get? So the addition of these numbers you get. Anybody got it yet? Say it again. 192. Point.
17145.
17415.
No, 145.
17145.
Okay, somebody else got that too?
Yeah, I got
Yeah.
that.
Okay, so you added up all those numbers and you get this, but now as a surveyor or a civil engineer, what should I report?
192.1.
192, or why?
Because that's the smallest amount of significant digits.
Right, and you're saying it technically, but let's just talk about in terms of surveying. We know which one's the estimate, right? The 7's the estimate, the 5's the estimate, the 5 and the 9, which means this thing is an estimate, this is an estimate, this is an estimate, this is an estimate, this is an estimate, and this one. So I only want to report one estimate, so that's the answer. So that's the rule with adding and subtracting of significant digits. But in our class, what we're going to wind up doing is we're never going to have to add those numbers with so many different numbers of significant digits or different estimates, because I'm going to use the same piece of equipment and measure something 4 times. I'm gonna get the same estimate, I'm gonna get the same number of decimal places, I'm gonna report the same number of decimal places. Done. Patrick?
Would you ever round?
Yes, we do round. Good, that's where we're going next.
Okay.
So now, in this case, I'm rounding, it's 192, and we're fine with that. But surveying and civil engineering is a little odd. So let's say I had let's do this one's not odd. If I had to round this, with this as the estimate, what would I get? What would I report?
193.
193. Everybody's comfortable with that, right? You're comfortable with the 0.1 keeping it as a 2, and you're comfortable with over 5 rounding up? This is the weird one. Let's say I have 192.5. In surveying, you round to the nearest even number. This is weird. I don't know of anything else that does this. Does anybody else? You round to the nearest even. So what would this become?
192.
192. How would if it was 189.5? What would it round to? 190. And why do surveyors do that? Well, if we keep rounding up at 5, we're kind of going in between, and we might get numbers that are off. So sometimes we round down, sometimes, well, we don't really round down. Sometimes we stay the same, sometimes we round up. Okay, so in the end, it kind of evens out the error. I mean, we want to minimize error in surveying, right? We're measuring things, we don't want to make mistakes, and we're going to be dealing with errors all the time. We're going to make errors, and I don't mean mistakes. The nature of the work is that we're going to measure some things a little bit off, and then we have to account for it. And many times, we don't even know. If somebody asks me to measure their site, I'm going to measure it, right? And I'll probably measure it forward and back, and I'll check my numbers with each other, which is precision, right? But we'll talk about that in a minute. But many times, I don't know what the true value is, right? I just have to be as detailed as I can. Since we're talking about this, what's the difference between precision and accuracy? Precision and accuracy. Matthew?
Well, is precision like the range of like your answers?
Okay, so range, but a small range of your answers, right?
Yeah, it's like
So if I get on the bathroom scale and I'm 150.1, 150, 149.9, 150, it's pretty precise. It's giving me the same values. If I got different values, it's not precise. But maybe I weigh 160 pounds. Is it accurate? If it's giving me 150, no, it's off. So the difference between precision and accuracy is precision is when the repeatability of a measurement. And accuracy is how close your measurement is to the true value. Are we taping now?
No.
Okay, cool. One thing we did in a class last year, which we're doing in this class too, is we're going to tape the lectures, and then we're going to post them. So if you want to watch them again, you can. If you want to see me on the weekends, you can listen to it. Okay.
Ned's gonna start this semester, you said.
Say it again.
Ned's gonna start this semester.
Yeah, right now we're taping. Brian, hi. Hi, Ron. Okay, so you're comfortable with the idea of the last number being an estimate, right? You got that. We're always measuring things with an estimate. You understand now the addition rule in significant figures. And now you also know how to round, whether it's less than 5, greater than 5, or 5. So now let's look at this other one. Let's look at C. Product of 21, I'm going to write the number down. Is it 2182? 2182.95 times 1.3. So which is the estimate in the top one? 5. Which is the estimate on the third? The 3. So when I multiply this out, 5, 27, 28, 7, 24, 5, 6, 5, 9, 2, 8, 2, 1, 5, 13, 17, 7, 3, 8, 2, 3 right here. Okay, well, I just multiplied this estimate by all the numbers, right? And I got this. So all these things are kind of, there's a lot of estimates in here now, right? So we can't really use that rule where, well, this is an estimate, so let's limit it. So, Porter, tell me, what's the answer?
It's just 3,000.
It's just, well, it's not 3,000,
2,878.
2,800. Because what you do is you look at the significant digits of the least number. So this one has 6 significant digits and this one has 2, so your answer can only have 2. So here there are 6 significant digits. Here there are 2 significant digits, so the answer has to have 2 significant digits. But again, we're not going to use this in surveying because whenever we're always going to be using the same number of decimal places depending on our instrument. So if our level measures everything out to 4 decimal places, we're going to always report 4 decimal places. If our theodolite measures to 3 decimal places, we're always going to carry it out to 3 decimal places. So even though significant digits can get kind of complicated, we're not really going there. Cody.
So it's 600.0, would that be,
Oh, let's see. Yeah, 600.0. So how many significant digits is it?
4.
So, I would have to look at the rules. This number,
4.
if the 0 is to the right of the decimal and there's a number that's significant, I think that this is 4, right?
Yeah, isn't it the zeros
If
on the right
If I'm
side?
hesitant about it, we used to, JG, last year, we covered all the rules in significant digits.
On the other side, then it's.
If it's on the
If
right.
it's on the
Usually
left
the
side,
zeros
it
don't
doesn't count.
If it's on that side, then it then they count.
Doesn't matter. You're not gonna need to know it.
But it's a good thing to know.
We used to cover significant digits a lot, for 45 minutes in this class, and JJ and the previous TA and Kelly and I realized that it's just, that's not where we need to go in this class. So you'll learn it in another class, but yeah, this is 4. Okay, so I wanna make sure that you're comfortable with that, and now, let's go and look at all these trig rules.
I have a question. I take it
Yeah.
division's the same.
Division is the same as multiplication,
okay.
and addition and subtraction are the same, okay? Zeke?
Do you ever use differential error propagation in someone?
We are going to be dealing with differentiating the error, so if we have an error of 2 degrees, we're going to have to distribute that error, and we'll
Right.
learn how to do it in each case.
Okay.
Because in class, we're going to learn how to measure horizontal angles and vertical angles, and horizontal distances and vertical distances. We'll talk all about, we're going to start next class, me giving you an introduction to surveying, all the type of terminology and such. Okay. But today I just want to make sure that everybody's comfortable with all the trig and the geometry. So let's take a look at, so this is on your packet. Right triangle. So I'm just going to kind of go through it a little quick. You know, I'm assuming you've seen it all already. So we have a right triangle here, right? 2 sides come together at 90 degrees. One side, these 2 legs are called X and Y in this particular figure, and the hypotenuse is called R. Okay? So Pythagorean's theorem, the relationship between these 3 sides is x squared plus y squared is equal to r squared. Trig functions, if I'm looking at this delta angle right here, the sine, and actually let me so the sine is the opposite side over the hypotenuse. So the opposite sine to theta is y over r. The cosine is the adjacent side over the hypotenuse. So for theta, again, the adjacent side is x over r, and tangent is opposite over adjacent. And now that I'm hoping, usually you see these right triangles just as in math, right? You run it through all these different problems, but now I'm hoping that you're starting to think about it in a three-dimensional picture out in the field, right? We were out in the field, right, and we looked at the ground sloping like this, and there's a vertical distance and there's a horizontal distance. It's very applicable to surveying. Okay.
Is there any way to turn off like the front
Yep,
lights
we
a
can,
little bit?
we can do whatever. So yeah, please, just tell me what you need. So, JJ, let's get some of that.
So we can see.
Try the other one. That one.
There you go.
Yeah, okay. Is that better?
Perfect.
Okay, and then on a general triangle means it doesn't have a right angle anymore, right? So we're looking at a picture of a general triangle right here. What's standard is to use the capital letters for the angles and the opposite, smaller letters for the sides. So just as in the right triangle, we were trying to find the relationship between the sides and the angles, it's the same thing here. There are two different laws. The law of sines, which says the sine of one's angle over the side is equal to the sine of another angle over its opposite side. And then the law of cosines. If I'm trying to look at this problem right here, this law of cosines, it has three sides in it, and it has one angle. So I could find the length of this side if I know the opposite angle and the two other sides. Is everybody comfortable with law of sines? Put your hands up. Some of you haven't seen it in a while. Are you comfortable with law of sines, law of cosines? So if it's something that it's foggy in your mind, you have to, between today and next Wednesday, you really have to work at it. And refresh your memory and look at that trig review and start doing some practice problems. And then, how did they get this area? How did they get that equation? So area of a triangle is equal to 1/2 base times the height, right? So this right here is the height. Here's my height, and the height here is a perpendicular, right? And here's my angle, C. So isn't the sine of C is equal to what? Opposite over hypotenuse, A. So the area is equal to 1/2, the base is B, times the height is, let's solve this, H is equal to A times the sine C. So I stick this in here, A sine C. And I got 1/2 AB sine C. Okay, let's go down the next side, the right side now. Okay, in this case we have a line, there's another line here that's 90 degrees. Of course, this total angle here of the line is 180, so it would be 90 on both sides. For a circle, the area of a circle is pi r squared, that's the area is inside, and the circumference is 2 pi r. The way I remember these is they both have a 2 in it, they both have an r in it, and they both have a pi in it. And if I'm squaring an r, I'm squaring a distance, I must get an area. That's how I remember it. Total interior angle in here is 360. We already looked at area of a triangle, 1/2 base times height. The perimeter is, if you want to put a fence around the whole thing, it's the distance of A plus C plus B. And then the total angle, the angle A plus angle B plus angle C is 180.
Do we deal with radians at all?
No,
Okay.
no radians.
What gradients?
No, I don't even know what they are.
I just see them on the calculator, and
Okay.
I've always wondered.
No radians, no gradients, no scientific notation.
No reason.
Do you know what the equation is to find out, so if you have a polygon that has, how many sides am I drawing? 5.
And minus
this
2
is-
times 180.
You know it already. Okay, so if I have 3 angles here, if I did this, isn't that wrong? right? In
Hard to
geometry,
see.
it means that they're all equal, right? So I should have went like this, 3. But anyway, so if I wanted to find out what the total interior angle is of this, how do I find out? Patrick,
You take the number of sides of the
the
polygon,
number of sides,
you subtract 2 from it
subtract 2,
for some unknown reason.
and
You multiply the whole thing by 180
180.
degrees, right?
Yeah, degrees. So the answer there is 180, right? So for a triangle, it would be 3. 3 minus 2 is 1. 1 is times 180. Okay, we're gonna need to know this.
Yeah.
Because when we're working with property, we need to know. I mean, some property might be 4 sides, maybe it's all right angles inside, maybe not. Maybe a property has a zillion sides, we wanna know what the area is. We need to know that equation. Okay, similar triangles, we use this a lot. So we have a little triangle, and then we have a large triangle. What's the same between these two triangles?
The angle.
The angle. This angle, of course, is the same. This angle is the same as that angle, and this angle is the same as that angle, right? So because they're similar triangles, you can make a ratio. Well, little a to big A is the same as little b to big B, or little c to big D, big C. And then, I guess, similar triangles is probably more geometry, right, than trig? How about this one? See?
Yeah, so in that regard, for me, you're talking about convex only polygons or general purpose polygons?
Say it again?
Is the polygon you're
Yeah.
on your board, is that only, the formula, is that only for convex or for all polygons?
All, because I don't even know what a convex polygon is.
I think that one's a convex polygon because all of the, it doesn't have like,
Just say the angle.
It doesn't have any
It is-
angle bigger than 180. There's no internal angles that are bigger
Okay.
than 180.
Right.
Yeah, that would not be a convex, yeah.
Okay, so what's this? This is a polygon too?
Yeah, that's also a polygon, yeah, but it's not
And this is
convex.
convex?
Yes.
Okay, my answer is different then. It's all
Well,
like
I just wanna
convex
know if that
polygons.
formula applies to that one too.
Say it again?
I just wanna know if that formula you wrote applies to that.
It does too?
I don't know, he's asking.
He's asking if that
We have to
formula
try
applies to
it,
that.
so I have to try it and figure it out. I don't know. I never thought about that. We're gonna get some good questions here. Does anybody know the answer to that?
Google it, is the answer.
yes, I agree.
Come on.
Why not?
Okay, I'll find out.
I need to learn.
Okay, so here, we have 2 lines, A and B, and they're parallel, and then we have this line that's coming through it. See how angles C and E and D and F are all the same, right? Do you remember the names of these? C and E are vertical angles. C and E are vertical, D and F are vertical, I and J are vertical. Don't know why, it's not really vertical. H and J are corresponding angles. How about G and J are alternate exterior? And D and E are alternate interior, but you don't need to know this, I just thought it was fun to look it up. You just need to know which ones are equal.
Say that again, D and the last one.
D and E are alternate interior. And then I and D together form 180, right? Let's see. Okay, and then the last thing is the distance formula. If you know the coordinates of 2 different points, and we are going to be dealing with coordinates, in surveying the coordinates we're dealing with are north and east, right? So we have, in math, we are always dealing with x and y, right? This is the positive x and this is the positive y. Well, in surveying, if we're dealing with the horizontal plane, this is north and this is east, right? So what does a negative x represent?
West.
West. And a negative y represents?
South.
South. And we're going to see things like that. We're going to manipulate values. And then here's the distance, the difference between the x squared, difference between the y squared added together under the radical. So now I wanna do some problems. And you can work in teams if you'd like. Let's do, problem 2 first. Problem 2, and it's in your packet. Do problem 2 first. And, where it says capital C is equal to 65 degrees. So C is equal to 65 degrees.
Sorry.
Right. We need a lot of science for that. Or number 2.
Yeah. Yeah, you can use,
You don't need it, you have to use the law of science.
So you don't think it's, well, that's just, number 3 is using the same figure, it's not using the same dimension. That's number 2. That's number 3. So, in this case, it's the opposite over the adjacent, right?
it is all, okay, good. I never got that question.
Yeah, it was what we
Now I
Oh, gotcha. Oh, C's getting
see that answer.
Sorry, I'm thinking about that, it's not always.
Oh, yeah.
It's true. Next week we're gonna find out, and then depending on who next, then you